All right, in this video, we are doing Introduction to Vectors. This is Unit 1, and I am on page 11. So, Introduction to Vectors. You've seen the word vector in your math lessons. In physics, we use vectors to actually do something. So, a vector is a quantity that has both magnitude, which is size, and it also includes direction. And this is going to be important because this direction is what separates a vector from a scalar, which is a quantity that just has magnitude. Some examples of vectors include velocity. So an example of a velocity could be 30 miles per hour east. This has both magnitude and a direction. The scalar version of this is speed, which we could just say the speed is 30 miles per hour. So the vector quantity is velocity, the scalar quantity is speed, and the difference comes down to the velocity also includes direction. Acceleration is also a vector. For example, Earth's gravity, the acceleration due to gravity, which we abbreviate in physics as lowercase g. G is approximately 10 meters per second squared down. Other vectors would include force, a very common one that we'll have here. Other possible scalars, we have things like volume. Volume has a size. Volume does not have a direction. It would make no sense for volume to have a direction. Mass is also a scalar. Mass is just a value with magnitude. There's no direction to mass. If you wanted to compare mass with weight, weight is technically a force, which does have direction. My weight is my mass being pulled down towards the earth, and the force is the result of the earth pulling my body against the floor, and that's my weight. Another scalar is distance. Distance is a scalar, things like 30 meters. It doesn't tell you much except for the magnitude. It needs to have a direction if you want it to be a vector. The vector equivalent of distance is displacement. Displacement includes both distance and direction, and that's how they are different. So now you see the difference between speed and velocity. Velocity involves direction. So what's the difference in these three quantities at the bottom? We have position, we have distance, and we have displacement. Position is where you are at this exact moment. there's really no magnitude and there's no direction. It's just, this is where you are right now. Distance has a magnitude. So let's say that I moved 2 meters from my original position. We have distance. But notice that I didn't tell you the direction. I didn't tell you which way that I moved, only that I went 2 meters. And that's a scalar. Displacement is a vector. This is where I might tell you that I moved 2 meters to the north. And this tells you how far you end up in relation to where you started.